have our polynomials, we have something that's called the leading coefficient test. Our leading coefficient test helps us determine what the end behavior is. So as we're going to the far ends of the graph, what's happening. So we have a couple of different scenarios. You have where it will look like a U shape, U-ish shape, or that I guess I shouldn't say U shape, because it can do various things in the middle. So let me redraw that. So it's going down to the far left and down to the far right. It's going up to the far left and up to the far right. Or it's going down to the far left and up to the far right. Or it's going up to the far left and down to the far right. Okay? So we can tell that piece of information based on looking at the leading coefficient and the degree. So you look at the degree and you decide is the degree even or odd, and then you look at the coefficient and determine if it's positive or negative. And that will tell us our pieces of information. So if your degree is even, you have one of two scenarios. You've got this scenario. Actually, I should show little dots in the middle again. Or you have this scenario. Now, there's several things that could happen. Like I could have this picture right here, or I could have this picture. All right, so there's several things that you could have in between as you're looking at your graph here. So that's why I have dots there. Okay, now this is our specific way that we write this. This part is saying as you go to the left, then this is going to the right. As you go to the right, this is going up. Oh, I said that wrong. As you're going left, you're going up. As you're going right, you're going up. Right? So you want to think of your graph. This is negative infinity, this is positive infinity, negative infinity, positive infinity. So as I go to the left, it's going up. As I go to the right, it's going up. Okay? Now, if it's a negative, you have this behavior. As I go to the left, it's going down. As I go to the right, it's going down. Okay? Then we have where it's odd. So odd looks like discoing to me. So this right here would be our disco. This right here would be our disco, right? So the way I help myself remember that is it would be really odd if you were walking down the hallways discoing. People would look at you oddly, right? So if it's odd, you're going to be discoing. If it's even, I refer to it as touchdowning, because this is the sign for a touchdown in football, and then you just flip it upside down. Okay? So here, as we go to the left, it's going down. As we go to the right, it's going up. So we'll get this picture. Or if the coefficient's negative, as we go to the left, it's going up. As we go to the right, it's going down. So we have this kind of picture. Okay. So we're going to look at two more things and then combine pieces of information. Now, we also have the max number of turns. So our max number of turns, so turns is where it makes a hill or a valley. The max number of turns of a polynomial that a polynomial can make is one less than the degree. Remember, the degree is the highest power, so we find that using n, which is the degree minus 1. Okay. Now, we also have this thing. So the degree is the max number of real roots, and it's exactly how many real and complex roots we have. So complex, remember, means that there are i's. Okay. Real numbers mean that there are no i's. So the maximum number of real roots is the degree, but if you're looking at how many real and imaginary, or real and complex, it's the degree of the number of that is the degree. Okay? So determine the end behavior for this polynomial, state the degree, max number of turns, max real zeros, and then sketch the graph. Okay? So I look here between 5, 4, 1, and none. 5 is the highest power. So our degree is 5, right? Our leading coefficient, I look at the number in front. So this is positive. Again, your coefficient you're looking, is it positive or negative? I'm not doing even or odd. So even and odd goes with the degree, but positive or negative goes with the coefficient. So the degree is odd. So that means that it's going to be discoing as we look from left to right. Okay? So it'll be this option or this option. So since it's positive, it's going to be increasing as we go from left to right. So it's going to have this kind of a shape. So then as we go to the left and as we go to the right. So in my end behavior, I always write this part because this is the same. Well, I guess I should put y here. This part will always be the same. It's this part that changes. So as we go to the left, it's going down. So mathematically, we say down by negative infinity. As we go to the right, it's going up. So mathematically, we write up as positive infinities. Since the degree is 5, the max number of turns is 1 less than that. So the max number of turns is 4. So your turns, this would be a turn, this would be a turn, right? So it's the thing that creates your hills or your valleys. So the maximum number of times I could turn would be 4. Okay? The max real zeros is the degree, which is 5. Okay? So I would have a maximum of 5 x-intercepts, or zeros or roots or solutions. But for how many real and imaginary, I would have exactly 5. Okay? So if I draw a picture of this graph, I could have something that looks like this. Now, I'm going to add this little piece here just to be slightly more precise. This is my y-intercept, because if I plug in 0, this gives me the y-intercept. So 1, 2, 3, 4, 5, 6, 7. Right? So it's a 5th power, so I just need to make sure that it follows this pattern. I don't go over 4 turns, and I don't have more than 5 times that it goes through the x-axis. Right? So this would be a fine picture. Now, there's only one actual graph, but we're just sketching just a general gist of it. Right? And then we'll add more and more as we keep going through our unit as to how precise our graph can be. Okay? I could have also had a picture that looks like this. Right? So I've got 1 turn, 2 turns, 3 turns, 4 turns. So I have exactly 4 turns. And then I've got 1, 2, 3 x-intercepts. So I didn't break any of my rules. So as long as your end behavior matches, you're not breaking any rules, your sketch is fine. Okay. Now, this one is not a great sketch because of the fact it doesn't follow our y-intercept. So this one is a better sketch. I could have also done, if I do our y-intercept correctly on that one, so I could do something like that. So we've got 1, 2, 3, but I've got 1, 2, 3, 4 turns. So that would be something that would be a slightly better sketch. Okay. Determine the end behavior for the polynomial negative x to the 4th plus 3x squared plus 4. State the degree, max number of turns, the real zeros, max real zeros, and sketch the graph. Okay. So this right here is our degree and our leading coefficient. So it's an x to the 4th, so that's even. So I'm going to be touchdowning. Since the coefficient out in front is negative, it's going to be going like this. So as x goes to negative infinity, y goes 2, and as x goes to infinity, y goes 2. So as I'm going to the left, it's going down, so negative infinity. As it's going to the right, it's going down, so negative infinity. The max number of turns, let's state our degree first. We had already talked about it, but I didn't write it. Our degree is 4. The max number of turns is always 1 less than that number, so 4 minus 1, which gives us 3. Okay. And then the max number of real zeros is 4. Okay. I should say max of real zeros. Okay. There's exactly 4 zeros when you have your imaginary and your real ones, but there's together. But if you are looking at the possibility of your maximum real zeros, there's only 4. Okay. So if I draw my graph, okay, notice here, if we look here, our y-intercept is at 4. Okay. I'm opening down to this kind of a shape. So I could have something that looks like that. I could have something that looks like this. Right. I could have something that looks like So I've got on the blue one, 1, 2, 3, 4 x-intercepts, which is the maximum number of zeros that I could have. I've got 1, 2, 3 turns, which is the maximum number of turns that I could have. Here I've got on the green one 2 x-intercepts, but 3 turns. On the purple one I have 3 turns, but 2 x-intercepts. I could also just have a picture, I need another color, where I have something like that, right? So all of these are possibilities of our graph. Again, there's only one actual graph for this, but just based on the information that we know so far, this is what we have. Okay, determine the end behavior for the polynomial negative 4x to the 7th minus 3x to the 5th plus 6x minus 2. Okay, so if we look at our leading coefficient and our degree is 7, which means that our max number of turns is 1 less, which is 6. Our max real zeros is the degree, which is 7. And then if we look at our end behavior, so this is an odd end behavior because our degree is 7, which is odd. So it's going to be discoing. So if we're discoing, I need to look at the coefficient. This one is negative, so that means that it's this kind of a shape, where it could do something in between in this middle portion right here. Okay. So as x goes to negative infinity, y goes to, as x goes to infinity, y goes to. Okay. So as I'm going to the left, this is going up. So mathematically we say up by infinity. As we go to the right, this is going down. So mathematically we say down by negative infinity. Okay. So then this is our information. I want to sketch the graph. Here our y-intercept is negative 2. It's starting, as we're to the left, we're at the top. So I could have just something as simple as that. Oh, I kind of missed. I could have something a little bit more complicated. Like that. Notice I've got 1, 2, 3, 4 turns, which is less than my 6 number of terms. And I've got 1, 2, 3 x-intercepts, which is less than 7 for our max number of real zeros. So again, there's plenty of graphs that you could draw at this point based on the information that we know.